I would like to present you our first speaker. Come. Yes. Sorry. Noah LUTZ. So he is a team leader in several engineering teams in Google. He is leading the efforts on bringing making a smaller the gap between research and implementing new machine learning models and applied machine learning. And he is also collaborating with plenty of researchers and institutions like EPFL on basically fishing for what is new and how can they apply it in industry or in other companies. But he was not, I was checking, he was actually not starting his life in Google. He started from a quite long career, and he was web developer, application developer. He finished his master in ETH on computer science and cybersecurity. And after this, he continued with learning or doing MBA in Berkeley. He's with Google for 12 years, and for first 9 years, he was working in a teams responsible for web security, and now working on TensorFlow. So, please.
Thank you, Pawel. All right. Thank you all for coming, and thank you, Pawel, for bringing together so many machine learning enthusiasts tonight. I'm really excited to be able to talk to you. Today I'm here to share my passion of bringing machine learning tools to all of you and everyone, so that it's not just accessible to a few, but hopefully to as many people as possible. My name is Noé, and as Pawel mentioned, I'm one of the leads at Google AI in Zurich. And today my presentation will be in two parts. First, I'll tell you a little bit about what Google AI is doing and how we think about machine learning at Google. And then I'll spend a little bit of time telling you what's new in TensorFlow. Okay, so I think you all know that we're living in a pretty exciting time, right? There's a vast change that's upcoming thanks to machine learning and AI. And the way we fundamentally think and interact with computers is changing every day. Here are just a few exciting examples of how machine learning is having a profound impact on people and users. Top left, you see some students in California who are trying to detect forest wildfires early on. On the top right, you see farmers in Africa who use image recognition and machine learning to detect and track disease that is affecting their crops and jeopardizing their food security. And on the bottom right, there's some cool work done at Google in Israel to detect and sort of simulate floods that are happening in India. And this information is used to then alert citizens that are likely going to be affected by these floods before they occur. And none of these projects would be possible without these new advances in machine learning. And this progress is sort of fueled by three main trends that I'm sure you know about. So the first one is this great availability of compute power that we haven't had before. And in this picture here, you see like these specially designed ASIC accelerators that are called TPUs that we launched at Google, but there's lots of others out there. And they enable researchers to build more powerful and bigger models than ever before. We also have big breakthroughs in machine learning algorithms. This is just one recent example, was this BERT algorithm that was announced and developed at Google. That's an innovative approach to do natural language processing that essentially helps the computer better understand written language. And then the third trend we're seeing is that there's a lot more data out there. We're seeing huge amounts of data sets from all kinds of disciplines being suddenly accessible to you all, to machine learning experts who can try to use them to improve their products or develop new ideas. Last year, we launched a Google Dataset Search with great success, and we're looking forward to seeing what you all are doing with this data. So this machine learning transformation also affects Google, of course, and has been so for many years. This quote is from our dear CEO, Sundar Pichai, and he says, machine learning is a core transformative way by which we're rethinking how we're doing everything in the company. And in fact, that's really true. There's very few products and technologies that aren't affected by machine learning technology today at Google. It transforms the way we do YouTube or even translation between different languages. And it enables totally new products that were not possible before, such as the Google Assistant. So this has led Google to create and found this Google AI part of Google a couple of years ago, whose mission is really to advance AI, not just for Google, but for everyone. And we achieve these through three different things. First, we conduct machine learning research and try to advance the state of the art. We do this by publishing papers and also open sourcing code when this makes sense. Second, we apply this AI technology that we invent we try to infuse it into all Google products so that it can benefit our users. And then third, we develop and open source tools and technologies that we make freely available so that everyone can benefit from this AI revolution and not just the big companies like Google. How does this look like? Well, on the research side, because machine learning is playing an increasingly crucial role in a lot of products that come out of Google, we invest in AI research centers all around the world. And here, every dot is one of those research labs. Here in Europe, we've been investing for the last couple of years. We have one big laboratory in Zurich, where we're from. But there's also labs in Paris, London, Amsterdam, and we recently announced our first laboratory in Africa, in Ghana specifically. Our centers publish hundreds of scientific papers every year, and we're hoping to advance through that the state of the art of machine learning and help share this information with the larger community. In practice, all this research obviously also impacts the product that we develop at Google. So there's very few products remaining that aren't impacted in some way by machine learning. Here, just a few: Google, Gmail, Search, Android Play, Chrome, Maps, and YouTube have all more than 1 billion users. And so they're a great avenue for our engineers to make use of their research in products and have a big impact on billions of users. I'm sure some of you have used the Google Gmail Smart Reply that's powered by machine learning, or seen the improvements over the years of our translation tools. It's not perfect yet, but it's much better than it used to be. And then the third thing I mentioned that what Google AI is doing is really open sourcing as much technology as we can so that we can help you and everyone else who wants to benefit from AI. TensorFlow is this open source platform that was started initially at Google AI, and that's powering the machine learning revolution that we're seeing. It allows for developers like yourselves, businesses, and researchers around the world to build these intelligent applications. And we've been really impressed by how the community has picked up this technology and done amazing things with it. So I already mentioned a few interesting examples of TensorFlow, and surely you've used it as well. There's sometimes TensorFlow is used in some less obvious corners of the world. So what do you think is the link between this milk bottle from Amsterdam and TensorFlow? Have you guys heard about this project? So you may have guessed it, it's actually cows. So given that we're in Switzerland, I figured it was appropriate to talk about how TensorFlow also helps milk production. We've heard this funny story from a startup in Amsterdam called Connectera, and they're basically developing this fitness tracker for cows. The orange device you see here in the picture captures data from cows, movements and wearables from the sensor, and then they use this data to build machine learning models in TensorFlow so that they can understand how the cow health is progressing and send these insights to the farmer. The system is able to predict and detect issues with the cow's health before it gets serious, and allows the farmers to intervene early, which keeps the cows healthier and also the milk flowing, of course. All right, this was the first part of my talk. The second, I want to get maybe a little bit more technical. As some of you may have heard, once a year there's TensorFlow Developer Summit, which happened just a couple of weeks ago in California. And so I wanted to use this opportunity to let you know a few of the new features that were launched at the summit. So together with some of my colleagues, I flew there in early March to present some of the work that is being developed in Zurich and to learn more about our community. A lot of the new things that were announced during these 2 days, I can't obviously cover everything here, but I really encourage you to go to the YouTube channel where all the talks have been recorded, and you can follow up if you're interested in a specific talk that I can only mention here today. So probably the biggest announcement that we've made a couple of weeks ago is this launch of TensorFlow 2.0 that just came out in alpha. TensorFlow 1.x has been an incredible success inside of Google, but also outside of Google. It has grown into a thriving community, much larger than we could have imagined when we open sourced this project 3+ years ago. Our users are building very clever, elegant, and useful things every day that we could never have come up with. And we think that tool has enabled a lot of creativity, which is great. But unfortunately, the first version we launched, as many of you have probably seen if you have used it, it can sometimes be really hard to use and sometimes even painful. So we've tried to take a lot of learnings from this first version of TensorFlow and built these lessons into the second version. We realized that what you need is really rapid prototyping. You need easier debugging in your environment, and the APIs may have appeared to be quite cluttered in the past. And sometimes you feel like there's no clear guides to how to get things done with TensorFlow. So we've gathered feedback, and for those of you who have shared feedback with you, thank you. We've heard very clearly that you wanted much simpler APIs, more intuitive, and a better developer experience. And you pointed out areas where our APIs were redundant and unnecessarily complex that slowed you down. And you asked for better examples and documentation. And we hope that this new release is a step in that direction. When we created TensorFlow 2.0, clearly the biggest focus was on usability. We have adopted Keras as the main high-level API for TensorFlow, and we have integrated it tightly into the framework. Keras gives you a clear path from building models all the way to deploying them to production. And it allows people to be productive once they get started. TensorFlow includes a complete implementation of Keras, but we went a bit further than what we had in the past. We've extended it such that TensorFlow, we extended it so that you have access from tf.keras to all the low-level and advanced TensorFlow features. So no matter if you're starting with machine learning, or if you're doing something really complex and distributing your Keras model across many, many machines, we think that this new API will be just for you. One of the big changes in TensorFlow 2.0 is the switch to eager mode by default. If you have played around with TensorFlow 1.0, you know that there's a declarative style to your programming. So you first have to build your graph and then execute it, which is very foreign to the regular Python programmers. In 2.0, TensorFlow behaves just like any Python code. So if you add two numbers, well, what you get in return, magic, magic, now it's finally two numbers. So hopefully that will make things easier. but you still get all the benefits of having a graph underneath. So you get robust program serialization and deployment, distributed computation, optimizations, and compatibility across serving and your training binaries. TensorFlow 2.0 is a major release, and we've taken the opportunity to also clean up a lot of our APIs. There was a lot of duplicate functionality that was confusing, especially when it behaved slightly differently. It was named maybe the same, but it behaved differently. In 2.0, we reorganized all the APIs and consolidated them, and we made sure that the APIs feel consistent across the entire stack. This is not only important for TensorFlow, but also for all the tools that were developed later on around TensorFlow that built the whole ecosystem. And we spend a lot of effort aligning those interfaces. We have defined exchange formats that work everywhere, and we're making sure that you can travel smoothly throughout the TensorFlow ecosystems with your model. So regarding this exchange format and making models reusable, I'd be hard-pressed if I didn't mention the launch of TensorFlow Hub that was recently launched at the conference. This is a project developed in Zurich. Last year, the team introduced this notion of reusable machine learning, where it's trivial to do transfer learning from existing models. With 2.0, the Hub technology that we built is now built into the core of TensorFlow, into the core of the TensorFlow framework. And what this means is that every saved model that you export, you can now be served using Servo, for example, but you can also reuse and re-import your models into Python for different teams across your company or maybe across your research labs. And we have seen great success in this model and this technology inside of Google, and we cannot wait to see how other companies and communities are using it. Today, you're especially lucky because we have Elizabeth here from the team who will present to you exactly how give you way more information about this TensorFlow change and launch. All right, this all sounds great. You all want to be part of 2.0, I'm sure, but what is it going to take for you all to upgrade your existing code? I'm sure you're wondering that. So we know that upgrades can be painful, and especially when it's a major version that changes the way the APIs work. So as you know, we probably have the largest code base in the world that uses TensorFlow 1.0. So we're very busy inside of Google developing tools, documentation, best practices to upgrade all these existing TensorFlow 1.x models to 2.0. And obviously, we're going to share that with the larger community, so share documentation, but also tools that we can come up with. As of now, you can already, we've already opened up this library called TF-Compat v1, which allows you to access any deprecated functions that your code may still be using. And this is true except for everything that's under TF-Contrib, which we've created a community-supported alternatives for TF-Contrib because it was removed from TF 2.0. And we've also published an initial script to transition your models to 2.0. It's mentioned here at the bottom. So try it out and see if it doesn't work. Let us know where the hiccups are. All right. So this is just very briefly about the timeline. We expect the release candidate to be done in late spring and then followed on by a final release. If you're the adventurous type, we encourage you to try out 2.0 and send us feedback and be part of shaping this release. OK. Last, you all asked us for a lot more and better documentation, so the team has worked really hard to overhaul the entire website for TensorFlow. There's way more examples, documentations, tools to get started, and we're excited to see these changes and what's to come. So now let me talk to the researchers in the room. I don't know if there are many, but a few launches are specifically meant for you. research inside and outside of Google have used a lot this TensorFlow framework to build state-of-the-art models. And here you can see the adoption, the number of papers that reference TensorFlow. So we've been really excited to see this, and we think they're one of our big user base we deeply care about. So our aim is for this framework to really be a powerful framework for research and experimentation. And in 2.0, this really begins with eager execution, which for some of you may seem very obvious, but it wasn't when we launched 1.0. As mentioned earlier, with 2.0, now the code runs much more like regular Python code. And this means you can write your code in a style that you're used to in Python without using session run anymore. This makes a big, big difference for debugging and hopefully for your productivity as well. Now, gaining this flexibility doesn't necessarily mean losing on performance. As you can iterate through this eager mode, you eventually may want to distribute your code onto a GPU or a TPU chip. And you can do this by decorating your functions with just a TF function. This turns your eager code automatically into a graph, and totally automatically. Yep.
Can this graph be dynamic or still static?
Do you know?
Can I switch out, like if I have tensor, can I switch out tensors into some different other tensors of different shapes, etc.?
Yeah, you can manipulate tensor as you want in this function. Is that your question?
No, like you can swap out tensors, like in PyTorch, you can use dynamic graphs. That's what I was referring to.
Do you understand this question?
I'm not sure.
Maybe you can.
Let's take it offline. Okay. Sorry, got off the thread. So, with this, you get back to the control flow is like a Python control flow. You get asserts, prints, and hopefully debugging will be way easier without jeopardizing performance, as I mentioned. For researchers, there's a lot of new tools and add-on libraries that we've launched or extended in the last year. So those are just a few here. If you're interested, I believe there's one talk for each of these libraries. And last but not least, I should mention also this library that is developed in Zurich. If you're a researcher, surely enough, you've been downloading these benchmark data sets that you know are pretty hard to do because you have a lot of boilerplate code. You need to change this data that you download into a standard format and a TF data set. And here, this is all done for you in this library. We support dozens of data sets that are typically used in research. And it's really easy to add one if it's not there. So we hope all these changes make researchers a bit more productive going forward with TensorFlow. And we hope it supports them in advancing the state of the art of the research. Now, I heard that many of you are ML engineers. So for you, I think there's also some exciting launches. You know better than researchers that to make real-world applications a reality, you don't just need to generate and train your model, but you need to push it all the way to production. And this has always been a strength for TensorFlow. Using TensorFlow, you can deploy models in a number of platforms. So models end up in a lot of places. They end up in servers in cloud, on mobile, and on edge devices, in browsers, in JavaScript environments, etc. And we have products for each of those. TensorFlow Extended, which we call TFX, TensorFlow Lite, and TensorFlow JavaScript. So TensorFlow JavaScript had just announced their 1.0 release. So that's a big milestone. And let me tell you a little bit more about TFX. So TensorFlow Extended is the end-to-end platform for managing every aspect of your machine learning lifecycle. This spans all the way from ingesting your data set and transformation, all the way to model at scale at the end of it. In orange, you can see all the libraries that we have open sourced so far. What this slide alludes to is that we're taking now a step further in providing components built from these libraries to make up a fully end-to-end pipeline. These are the same components that are used internally in thousands of products across Google to make machine learning, power machine learning in Gmail and other places. These components are also used in many other companies, including Airbnb and Twitter, as you could see on the TensorFlow blog. But components are only part of the picture. This year, we really plan on putting all of this together and providing an integrated end-to-end platform. First, you can bring on your own orchestrator of jobs. So in this case, we show Airflow, Kubeflow, or Kubernetes, but you can bring whichever one you want. No matter what orchestrator you choose, the TX components integrate with the metadata store underneath. And this keeps track of all your components run, your artifacts that went into them, the artifacts that were produced by the pipeline. And this enables like advanced features like experiment tracking, model comparison, etc. I think there's also a specific talk, if you're interested in that. Clemens, the PM for TFX, gives a nice full hour-long talk about how this all fits together with a real-world example. Okay, last but not least, what's in it for students? So we're excited to launch 2 new classes on Coursera and Udacity that talk about TensorFlow 2.0. And these classes don't assume any prior machine learning experience. If you're a student and you're an enrolled student, for the first time, you can now participate in the Google Summer of Code and help us at TensorFlow develop this platform and contribute to this open source effort. And then last but not least, a couple of months ago, we started to gather stories about Powered by TensorFlow campaign, where we heard from many of you in the community about what you've been building with TensorFlow. We were so excited that we decided to start a hackathon that started at the Dev Summit, but you still have about a little over a month if you want to contribute. There's this DevPost hackathon, and there will be a winner at the end, and there are lots of cool prizes. All right. I think this concludes this first talk from us. Hopefully, it gave you a little bit of an overview about everything that's new with TensorFlow. I really encourage you to go to the YouTube page, because there's lots of interesting talks by the people who actually built a lot of these things. I'm just here sort of communicating everything that I've learned from there. So, oh yeah, do we want to do questions now and after every talk? Okay.
After every talk,
yeah.
So we have some time for questions, so please ask questions. No questions. So I have a questions. A lot, but I will ask just one. So you are leading how many teams in Google? And what they are doing?
There's 3 teams, total of 17 people, so we're quite small. There's one team is a team of expert machine learning practitioners, and their goal is to go around Google and help other Google products improve their use of machine learning. Because as you know, it's different from software engineering, and even inside of Google, we have to learn how to change our behavior and have mode of operandi for engineering teams to adopt these machine learning technologies. The second team is TensorFlow Hub, which Elizabeth is going to talk about. And then the third team does applied research in the auto machine learning space, which Quinton's going to talk about. Yes?
I just have a question about, when you think about the future of machine learning, do you think it's going to stay at such a big hype? Or is it eventually going to get carried on by something else?
Are you alluding to, like, you think there's going to be another winter, or? I think even if machine learning doesn't progress much in the next 10 years, let's say, I think there's so many opportunities to change already existing systems in existing companies, and they could all benefit from machine learning. So I don't think we're out of like applications for machine learning in many companies. I think there's a lot of new cool things that are going to come out of it, even if the state of the art of machine learning is going to, for some reason, slow down to evolve or something like that. I think your job is pretty pretty secure if you know what you're doing.
So, one more question.
Oh, I didn't. Oh.
Yes.
The question was, is that okay? Sorry, I forgot to repeat the question. One more question?
One more question? Anyone? Okay, so thank you very much.
Sure. Yeah, you're welcome.